And I'm live. That is cool. And today is 13th of August 2025, Wednesday. And I will just simply start doing questions, which is what I am here for. And yeah, CB31, this question, maximal and stopwatch. And I can put this thing up, which is cool. It now even has a background shadow, as I can see. Shit, what that looks strange. Yep. The problem statement has recently been changed. View the changes. It was during the contest. Yep, it was strange and now it is unstrange. Okay, and I'll start Emacs. Yep, increase the size a little bit. Go to my folder, start new vim, update new vim, update everything here, and go to the correct folder here, and yep. Okay, all right, all right. Up, drink a bunch of water, and seems like it is fine. It does say excellent connection. That is cool, and begin. Okay, perform at most k operations, and the highest bit. I have to return the highest bit. Okay, and n and k. Okay, and AI can be very big. AI can be very big. Makes sense. Makes sense because of this. Because of this. But can I even take this number n? 2 power 31? Yeah, 2 power 31 is the 31 first bit. Okay. It is guaranteed that the sum of n over alt. Okay, focus. It is a simple integer. That is cool. Alright. N and k and Maybe this is correct now. See, and is there something wrong with this? Like, I do not see any video, which seems it might be bad. Yeah, it is fine. It is fine. It is fine. And accepted. That is awesome. That is awesome. This question is cool. This question is cool. Maximal, and this question is cool. Okay, let me write 18 minutes here, and now I will explain what I did. 18 minutes, that is the time it took me to solve this one. Accelerator, and yo, let's go. I can remove this thing now, which is cool. And yep, so in this question, this is cool. I would first I would explain it, then I can look at the tags. Greedy, bit mask is something that I did. Greedy method. Yes, greedy method. Yes, you call this greedy, and the approach that I took. And yeah, that's cool. Maths, it did use maths. So in this question, I have been given an array of numbers. I have some numbers A0, A1, and dot dot dot, stuff like that, and another number called K. And what I have to do, what I can do is given any number, and if I represent my number as bits in binary, which in binary with 32 digits. I am here just using 6 digits, but let's say I have not 32 but 31 at max. 31. Can I use 31 bits? Yes, I can use 31 bits, because if I'm using an integer takes 32 bits, and the last bit, the first bit, is used to represent if it is a negative number or a positive number. And yep, and the maximum value of j I can take is also 230, and that would be 2 power 31 minus 1. No, no, this just 2 power 30. And wait, when I say 2 power 1, I'm actually using 2 bits. Okay, that makes sense. That makes sense. So if I represent any number a in binary, let's say, right, and I have been given another number, let's say k, which is, let's say, 3, and I have, for example, two numbers, right? 0 1 0. What I can do is take any three bits in either of those numbers, and I can change that 1, change any of these 0 to a 1, and what that and at the end with this operation my goal is to take the AND of all of the numbers that have been presented to me and maximize it. And since I want to maximize, I would like to flip the MSB, most significant bit, which has the highest value, right? You would like to flip that biggest bit. So I would see my algorithm is take this 3 and see, can I use my remaining number of k operations to turn this bit in the final AND equal to 1? And yes, if it already isn't 1, I can do that. So I would use one of my operations here, and now this is not a 0, this is a 1, and now I have used one of my operations. Now I only have two operations, and then I move on to this bit. Here, this bit in the final AND would result in a 0, and to make this into a 1, I need to do two operations to flip both of these zeros into a 1. And how many operations do I have? I have two operations, so I can do this. And now I have 0 operations, and this bit would also turn into a 1 in the final answer. And now I have no operations, so this would be the maximum AND that I could found. And yep. And how am I doing this? To calculate this thing, I have an array of size 31 in which at 0 index represents how many bits I have at index 0. Like here I had only one bit at index 0, and I can fill this whole thing in the same way. And let's say I am at the end, right? This is my big array, and yes, 0 starts here. So this is kind of flip because MSB is represented here on the left, and in the array the MSB is represented on the right, so just bear with it. So here I originally had one up bit, and in the second last one, in the second MSB, I had no 1 bits, so this is 0, and initially my number of operations was 3. And to make this bit into a 1 in the final answer, I know that I have two numbers in total, and in this place, to make this into a 1 in the final answer, I would like to make all of those two numbers bit at this position into a 1, and I already have 1, so I need to flip 2 minus 1 bits, that is 1, and I can do that because I have total 3 number of operations. So I do that, and while I was taking the input, I took the AND of all the numbers right here. When I took a number, I took its AND, and yes, I did that. So the answer variable which I have, which has the AND, the original AND of all these numbers, will have this bit equal to 0 originally, because one of the bits, this thing was 0. So when you take 0 and 1 and you get 0. So I just need to flip this bit in my answer variable. And how am I doing that? I know the position of this thing. Position is 30 30th index, and I can just take one, left shift this by 30 and add this number to my answer, and that would flip this bit 1 to 1 in my answer. And then I move on to the second one. Here I have 0 1 bits, and in total I need 2 1 bits. So therefore I would need in total 2 1 bits, and I have two number of operations remaining. I can do that. I can flip this, and then I can left shift 1 by 29 and add that to my answer, and then my k would be equal to 0. I do not have any operations remaining, so this is my answer, and that is what I'm doing. I'm just taking in the input number, every number, and for every number I am iterating through all of its bits, which is a nice thing. See, I start with the LSB bit at position number 0 till bit at position number 30, since this is 0 indexed and I have 31 bits in total. I increment B, and how do I see the bth bit at the bth position? I left shift C by B amounts. So if I have a number like this and I want to find the bit at position number 0, if I left shift this thing by 0, this just like does not change. This is all, this will remain as it is. And then I'm taking AND of this thing with a single one. So if I take AND of this thing with a single one, if this last bit is 1, I will get a 1, and if this bit is 0, I will get a 0. And let's say I want to find the bit at position number 1. So I would take this number again, the original number, left shift it by 1, and I would get 1101. This would be my new number, and take its AND with 1, and since one of these numbers is 0, this will result in a 0. So I know that the bit at the position number 1 is 0, and that is what I'm checking for. C, left shift C by B and take its AND with 1, and if there is a bit, then increment the number of bits at B position by 1. And then I am simply iterating 30 times for every bit from the MSB. The most significant bit is at position number 30 because this is 0 indexed and I have 31 bits, and I see that the number of bits that I would have to change, flip in this to make this bit in the answer equal to 1. And if that is either equal to k or less than k, and it is the number of bits that are flipped is less than n. If they are equal to n, then it is already flipped and I do not have to do anything there. Then I remove from k the number of operations that I did and increment my answer the way that I said just now, and then output the answer. So that is very cool. And now I would love to see the tutorial. What do smart people say about this? H. This was contest division 4, and H. Shit, this was the last one, which means it was the hardest. The optimal strategy is to use greedy, take the highest bit. We have enough operations to set in every array element. To do this, we maintain a count for each bit with the number of elements that have it set already. Yes, the count to set, and I guess they tried to use latex, but they were unable to. And we go from the highest bit to the lowest. If we have enough operations left, we set the bit, subtract its count from the operations, and move to the next lower bit. If we don't have enough operations, we move onto the next lower bit and don't modify the operations. We stop once we processed bit. The time complexity is AI. The maximum number, AI is the maximum number, and n log of this thing, with 2 would return how many bits I have flipped. Yeah, makes sense. But I can just take that as n as 30 because at most I have 31 bits. So yeah, that one was cool. And now I can move on to the next question. Start my stopwatch again. 18 minutes for the first question, and chat ban would be the next one. And I can flip this thing. Yep. And problem solving mode is going to be on. Go. and x. Okay, cool. This should work. I have implemented binary search and let's see how that goes. Bro, what's your age? 21, I suppose, if I'm correct. As far as I know. And I messed up. So you're stream 4 5 days ago, and that I also started solving on Code 46. I solved all iterated. Now solving on that is question. That is that is really cool. I am solving this question right now. Chat ban. Yeah, chat ban, not ben ban. 1300 level, and this seems okay. I do not want to look at the like the input for which I got the wrong answer. Now I need to debug this thing. Okay, why did I got the wrong answer? I'm implementing binary search. Here I can uh, write a specific if statement checking for a edge case and make my solution correct, but I want to make this general. This should work given the invariance that I have chosen, or maybe I have to change the whole invariance that I have chosen. Okay, let me change the whole thing. 0 means the base, r is p minus 1, L, the answer is either equal to L or greater than L, and R should never be the answer. R is never the answer. So my answer is between R and L. And whenever my range R minus L gets equal to 1, that means I only have one number which is equal to L. I can jump out. So I take the mid. I have to change the way that I'm taking the mid. And here value should be maximum. Okay, that is why I chose them that way. Maximum minus, I have to make a decision now. How do I want to calculate this? This is binary search. And I'm checking to see if this holds the invariance throughout every iteration. And if it does, then it should work. Then it will work. Okay. Uh, Oh, shit. It never ends. I'll change the way that I'm taking the value and yeah. Okay. Yeah, this might work now. Wrong answer. Okay, I'm just unable to apply a simple binary search because the order has changed. That is why it is messy. Yes, else, yeah, yes, this one was working. Yep, this one was working. And this one was also working. Okay, I will have to see how that goes. And we will just see binary search, the invariance. I will have to see which invariance holds, and I'm expecting wrong answer. Yeah, wrong answer. That is, yeah, okay. Which question or approach are you binary search? I have thought of a solution, but it is brute force, so it will give TLE. Yep. Is there some equation through which we can get it directly? Why are you using binary search for? Because, okay, now I would have to look at the solution or just how to apply the binary search. Because here I have a pattern like this, okay, somewhat like this, which grows up, and then goes down. And what I'm concerned with is the height. Let's say, uh, your ans this is the biggest tower, okay? And X is a sum of heights of these things. 3, 4, 1, 2, 3, 4, 5. Yep. X is the sum of these heights, and your okay, I have in my case divided the answer in two different uh, options. Either, so this is 1, this is k, and this is 2k minus 1. So either my answer is in this range, I'm applying a different solution when my answer is here, and a different solution when my answer is here. And what I'm checking for is I find some middle point, and there I see what is the summation of all of these things till this point, and I compare that with x. And if my x is greater than this sum, then I know I can send a few more emojis. Therefore, my answer would be to the right. And I change my left pointer to point here, and my right pointer is pointing here. And just by doing binary search, I can figure out where my left pointer is going to be. And this is what I do on the left side. And calculating these sums on the left side is easy because let's say my mid equals 3, then I am trying to calculate the sum for the first 3 towers, and it is easy. I can just do m into m plus 1 divided by 2. That is the sum of these three things, the sum of first n natural numbers. But calculate, and this portion of my answer is correct. I know that for a fact because it is very simple binary search. But here, here is the problem. Here my left, I started at 0, and left represents, I know when I am searching in this block that my answer is going to be to the right of this kth tower, and left represents how much right do I have to go. And if it is 0, that means my answer is just this thing. And if it is 1, then I know my answer is either till this tower or to the right of it. And my right here is k initially, which is 0 right here. And the invariance is that k r is never the answer. Therefore, my answer lies in this range L, R, and L is inclusive. L could be the answer or could be smaller than the answer, and R is never the answer. And I see when the size of my range goes equal to 1 or 0, then I know that my answer is right here. And yep, then I know my answer is right here, and actually K could not be the answer. It is easy to do this on the left side because the sum grows. But on the right side, when I'm calculating the sum, let's say my midpoint turns out to be here, then I have to first find the sum of all of first I have to find the sum of all of these towers, and then the sum of these towers, and subtract this smaller number from this bigger number to get the sum of these towers, and then compare that to x. And if x is smaller, then I have to put shit. I think should not include the tower that the mid is pointing to. And if mid equals 1, it represents this tower. If mid equals 2, it is this tower. Mid equals 3 is this. Mid equals 4 is this. And this is like so crazy because I have my right pointing k here, and because this is how I'm doing things. My counting for mid starts from the right like this 1 2 3 4, and my counting for left and right starts from the left 0 1 2 3 4, and these number lines are reversed, and I need to find some common notion between them. Okay, if this is my kth tower, this is my k plus 1th tower, k plus 2 3 and dot 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 till k. This tower is k. Okay, and I am supposing I have at this point I have subtracted this whole thing from my x, so my x only has summation for these things, and my L initially will have the value equal to 0, because let's say I have some towers like this, and X covers the first tower and only a few things in the second tower. Then I would like my L to point to this thing. So either when I get out of the loop, my answer is at L if this region were not here in X, or it is L plus 1. That I can check when I get out of the loop. And yes, I'm going to start my counting from the left. So this is 0, this is 0, this is 1, this is 2, 3, 4, dot 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 till k. K is outside. This last tower is k minus 1. Right. Yep. That last tower is k minus 1, and I initialize my r equal to k. So either my answer is at k or less than k, which is not a good invariance. No, it is not a good invariance. So what I can do is check this beforehand, which I am doing actually. If my x is greater than or equal to the sum of this whole thing, then I can output the whole thing right here, 2k minus 1. But if it is lower, then, and by lower, it could also be here. And I can actually check for this also, mx x if, and this would not be the answer because this value is equal to 1, and reducing 1 from this would put my x at max here, right? So this is always the answer. If, yeah, this is always the answer, then this is never the answer. Therefore my invariance will hold, and since I start my r at this position, no, I if this is true, I can start my r at k. K is fine, k is fine, k is never the answer. So my answer is in this range. L is inclusive and R is not inclusive. So R is never the answer and L is the answer. So if at any point the range of this thing, which is R minus L, this thing goes less than or equal to 1, then I only have one thing to consider. My L would be the answer, or L plus 1 would be the answer, which I can check for. And I will run my loop while R minus L is greater than 1, because then I know at least there are two elements in my range, and that is what I do. I should initialize this like this, and this equals k, and while R minus L greater than 1, and then I find the midpoint. Okay, this this is like inverse of binary search. Yo, Big Bunny, morning. I've seen you before here. And then I find the midpoint, and I now have to make a decision. When I am calculating the midpoint, let's say my midpoint is comes out to be at this point. Do I include this tower, or do I not include this midpoint tower? Because if I do include this midpoint tower, then if the sum of this included tower could either be lower or equal to it, equal to x, and if it is lower, which means x would be somewhere here, or if it is equal, which means x would just barely do cover this, then I can put L equal to this thing. Makes sense. And if it is higher, if this sum is higher, then it could be higher in two cases. I think I should not include it. It does not matter if I include it or not, because if this is a higher, if it is higher, if it is higher, what does it mean? If the thing is higher, then what do I want to make my R equal to? I cannot make my R equal to mid, because midpoint could actually be the answer, and R does not include the answer. Invariance would be broken, so I can do R equals mid plus 1, but that would, maybe that would never close the range. Yep, that would never close the range, and that actually makes sense. I can do equal to 3 less than while there are two elements, at least 2, because if the range is at least 2, then answer is either L or L plus 1, and that makes sense. L or L plus 1. Now mid, and I am going to include the mid tower. And how would I find the summation of this thing, to find the summation of this thing, I have already found the summation of this thing. I can easily find the summation of this thing and subtract this smaller thing from this bigger thing and get this sum. And what is this smaller thing? This smaller thing is going to be k minus mid, but not. Okay, here I have three towers, and one is this is two, this is three, and k in this k minus one is six, and I need to find the sum of three towers. K minus one minus mid will give me this sum. Okay, makes sense. K minus one minus mid, and here k minus one minus mid, k minus mid, and no plus one. K minus one minus mid, because the sum of first n natural numbers is n into n plus 1 divided by 2. So k minus 1 minus mid into k minus 1 plus k minus mid divided by 2. That gives me this sum, and I am subtracting that sum from the maximum possible sum, which is this thing. And after that, I am comparing this sum where I have included this kth tower. And now, if this value is greater than x, I can make r equal to this. And okay, now my answer is either at L or lower than L. Therefore, I would like to remove all of the towers till L, L included from X, and if there is still X, then the answer would be L plus 1. So, X minus equals K minus 1 minus L into K minus L divided by 2, and if X greater than 0, greater than 0, because it could also be negative. If X is greater than 0, then answer is L. Answer is K plus L plus 1. Otherwise, answer is L. And there is nothing as capital K. And now, I hope this works. This binary search. Okay, it keeps on going. Okay, my bad. It keeps on going. If I reduce the maximum range to 1, no, that won't help. That won't help. That would actually be bad. Wait, R is not the answer. L might be the answer, or L plus 1 might be the answer. Yes, and this makes sense. Greater than 2, I would always have two numbers, either L or L plus 1 as my answers. Int mid R. What the heck is? Okay, that is horribly wrong. R is the bigger number. Wrong answer is better than no answer, and that is horrible. Okay. Three, and that is bad. Nope. Shit. Binary search. Okay, I will now look at the solution, how to do that binary search. How many questions have you solved on lead code so far? I guess, Mr. Praful. It is about 130 or something, or maybe 150. And binary search. Shit, this blood test is a nice guy. Educational rounds. Yep, educational rounds are cool. And C chatbot. And what? Oh, shit, is this because I have a plugin? This plugin, latex. Uh, would like to like not run this plugin on code forces. I can remove this for now and yeah, remove. Now I should see the correct thing. Yep, now it is cool. So this is pretty obvious binary search problem. Yep. We get banned after y messages. We also get banned after y plus 1, y plus 2, and so on messages, and vice versa. We don't get banned after y messages. We also don't get banned after y minus 1, y minus 2, and so on messages. For simplicity, let's split the problem into two parts. We check when if we are getting banned after y messages. Let's handle cases for y lower than k and equal to or greater than k. I have also done the same. Split my problem into mid or greater than mid or lower than or equal to mid. And you recall that the sum of arithmetic progression is y into y plus 1 divided by 2. Yep. And let it be cnt y. Okay. The first case is pretty simple. The number of emotes we send with y messages when y less than k is this. Yes, which is cnty. So we only need to check if cnty greater than equal to x, and if at any point cnty is greater than or equal to. Yes, yes, and okay. The second case is a bit harder, yes, but it still can be done using arithmetic progression formula. First, we send all messages y less than k. The number of search messages is cntk. Then we need to add k minus 1, k minus 2 plus till y minus k. This number equals cnt of k minus 1, cnt of k minus 1, cnt of k minus 1 is there. Yes, cnt of k minus 1 makes sense, and minus from that 2k minus 1 minus y. 2k minus 1 minus y, that also makes sense. That also makes sense. And we send all messages from k1 to 1 and k minus 1 to 1 on the right side, and subtract messages from 1 to 2k minus 1 minus y from this amount, and subtract messages from 1 to 2k minus 1 minus y from 1 to 2k minus 1 minus y from this amount. The final answer would be this, and we are checking for that. And yep, the time complexity is like this, and yep, the solution. The second while loop is crazy. The second while loop in this part, the second binary search is kind of a bit complex. And let's see. Left is initially equal to 1 and right is 2k minus 1. And what is the invariance? Invariance is nothing while L is equal to or less than R, and mid equals this thing. Mid equals the summation of this thing. Right shifted by 1. That is very cool. Right shifting by 1 means division by 1. means division by 2. That is a nice, beautiful thing. And if mid greater than k, then this. And if mid lower than k, or yeah, if mid lower than k, then get mid. If over, then rest. And okay, binary search is tricky to get right because it can be very wrong. And okay, so I will do this question offline of the stream at some point. I would like to add this question to remarks. I have already spent review saved. Yo, binary search. I want to apply this on my own. Yeah, yeah, yep. Okay, I can move on to the next question now, which is this array elimination. This one was tricky. Binary search. Okay, I'll drink a bit of what shit. I have shit. I had this thing on the whole time, which is crazy. And now on to the next question, whatever it is. Div 1, question number A. Shit, easiest question in Div 1. Let's see if I can do even one question in Division 1. I will start the timer and start solving the question. Let's go. Let's see. Operation of elimination. Okay. That is cool. 1 2 1 1 1 1 1. Okay, and I would have to see why this is working exactly, like rigorously. If this is correct, that is going to be cool. Good luck. Thank you, Addy, Mr. or Mrs. I don't know, but thank you. And this is correct. Seems like so, at least. Shit. Okay, cool. It is correct. And 13 minutes is very cool because I thought I would not be able to solve this one. So 13 minutes is actually very cool. I can write 13 minutes here and move on to do the next one. But before that, I would like to do what explain what I did. So here I am using bit masks and I am, I guess, using greedy. You can call it greedy. Yep, greedy bit mask maths number theory. And the thing that I am exploiting is this. Let's say here I have these four numbers and this is their binary representation. And 30, this is 30 and this is 7, this is 25 and this one is 19. And if I choose k equal to 1, then I would be able to choose only one of these elements at a time, and their and with themselves would be the element itself, and then I would have to subtract from the number the and that I got. And so k equal to 1 is always correct because I would be able to make the array equal to 0 for k equal to 1, but just by choosing these elements individually. But in this case, when k equals 2, I have to choose two elements. And my main goal is to make all of these 1 bits equal to 0. And when I have chosen my k equal to 2, what I want is when I take AND of, let's say, these two numbers, this bit would be preserved because they are both 1, and these other bits don't matter at this point. This bit is going to be preserved in their AND. So when I subtract the value of their AND from these two numbers, they will be converted into a 0, which is cool. And I can see when I do the same thing here, I have only two 1 bits and I have to choose only two elements. And can I make here a choice in which by choosing two elements, I can preserve this bit, and yes, I can just choose these two elements and preserve the bit and make it equal to 0. And here for this bit also I can choose these two elements, and for this bit I can choose these two elements, and for this bit first I can choose these two elements and then I can choose these two elements. And so k equal to 2 is going to work for this. And if I choose k equal to 3, then there is no possible combination. Uh, I want to remove these two bits and make them equal to 0, but I have to choose three elements, but at max I only have I only have 1 bits. I have only two 1 bits. So I have to choose one of these zeros, which would make the answer of that and equal to 0. And that subtracting 0 from 1 is not going to replace this 1, which is not what I want. So 3 is not going to work. And that is like the thing for all of the other keys that come later. And how am I exactly doing this? I first take in the number that I want, like I take in the input, and then I'm going through every bit in that number and adding it to my array of bits. And what is this bits vector? This bits vector contains the number of ones up bits that I have at index 0, at index 1, index 3, and so on. And then I start iterating from my possible answers, which can range from equal to 1 till equal to n. And I start initially with the assumption that the current value of I is correct. And then I go through the number of bits and I see if there is a remainder in any of those cases, then I won't be able to convert that 1 bit into a 0 bit. Or maybe instead of remainder, I could choose I is lower than. Because if I is yeah, this is more correct. This is actually more correct. Instead of saying no, remainder is more correct. Shit, my bad. Remainder is more correct. Because in this case, I'm looking for remainder equal to 2 because I can choose these two, select these two in pairs of 2. So remainder is more correct. And if I do find that with the current value of I will have some left bits over, then P equals false. It is not possible, and I break, and at the end I see if P, if this current value of I is possible, then output that value, and at the end output a new line. So that is cool. I was able to do this, which is a cool fact. And I would like to see the tutorial for this one. What does the tutorial say? It was the first question in div 1. So that is cool. I was able to do it. And okay. And what is this? The tutorial for A. The tutorial is loading, but what is this then? Array elimination. Yo. Elimination, next question would be deep down below. I have done 2 questions till now, and it has been, wait, I can remove this thing. It has been 2 hours and 2 questions in 2 hours. That is bad. But I did the first question in 13 minutes and the sec for this question in 13 minutes and the one before that in 18 minutes. It just took more than an hour on this chat ban question. And because the binary search in this seems a bit complex and I would have to think about it for longer to get it right, and the tutorial for this thing is not opening. So I can go to the next question, which should be this one, and before that I will have to go to the washroom and I will be right back. Yep, I'll be right back. So, and me back. Me is so bad. Again, put this thing up, this thing, and move on to the next question. This now, this one. Okay, okay. It's going to be cool. Let's see how much time it takes. Okay. In a certain video game, before starting, start the stopwatch. Okay, that is cool. Minimum possible value. Shit. Okay, makes sense. Okay, that is cool. And should this work? I think this should work. But that is not enough. Before submitting this, I have to be absolutely sure that this will work because I want to get this right in the first try. 43, 13, 13, 43. Okay, I am for every cave calculating in a efficient way what would be the minimum strength that my hero would need to get in there and how many elements are in there. And then I go to the cave that needs the minimum amount of strength, and then I increase my score as much as I can. Yep. If current value is greater than the string, then I increment the current value. And else if not, that is, I would need to increment my answer, and my new answer would be the greatest value to get to this point. And yes, and how would that affect my C value? It would add the score that I would get after exiting this cave. And from that, since my new answer is not answer, but my initial value is going to be data I dot second, this initial value, and I think this should work. I believe so. Submit the VP curve. Let's see how that goes, and good luck. Thank you. What is your lead code rating? There is rating on lead code. Kunal Shinde. I didn't know that. There is ranking. I've seen the ranking. Wrong answer. Shit. I am missing something. Hello. Something is amiss. Okay, something is wrong. Something is wrong, and I have to figure out what the way that I am filling this data structure, this vector of pairs is correct. I know that this is the most optimal, efficient way to fill this, and not just the time complexity. This is the correct way to fill this. This is the correct way to fill this. What would be? This is the correct way to fill this, and then sorting this is a good idea because I can go in any permutation. I can go in any permutation, and I am sorting this on the basis of the lowest cost that would the cave in which I need the minimum amount of score is first, and then the is first, right? And yep, this is a greedy algorithm. And if two caves have the same minimum amount of score, then I'm judging them on the amount of score that I would get when I get out of it. And this is good. This should work. Is there something wrong with this? Maybe there is something wrong with this thing, because this whole thing this whole thing seems correct, right? There is no obvious reason why this would be wrong, but this thing could be wrong. I am taking in the current value, and yep, I'm taking in the current value, and I don't need L here. I'm taking in the current value, and I'm comparing that. Can is my current value great? Okay, that makes sense. That makes sense. That makes sense. That makes actually a lot of sense. And SC score, or maybe it doesn't make sense. It is actually C plus 1, and C plus 1, and okay, and else if this is the case, then do this. Else SC plus plus, and I also have to update SC here and compare this thing with SC, the current value. This is my current value, and if I cannot reach this, then see how much more value would I have to start with. Data I dot second equals C minus SC. That is how many more points I would have wanted. when I started this whole thing, and what would my current value be? My current value would, since I have gotten through this point, SC plus SC equals C plus 2. Since I have defeated this current monster, so C plus 1 to be able to defeat this monster, and then plus 1 because I did defeat this monster. So my score increased by 2, and at every point wherever I am, my score is equal to the current score plus 2 at minimum, at minimum. And here, when the rating of my monster is greater or even equal to, because yeah, even equal to, then also I have to update this. If it is equal, then plus 1 is what I need, and C plus 1 is what I need, and SC is what I have. So add the difference. Plus, not equal to, but plus the initial score plus what extra I would have needed. Right. What extra I would have needed, and current score would be C plus 2, which makes sense, and otherwise just an increment SC. Wrong answer is crazy. Let's simulate for this one. Here, when I got initially my score would be 13, and then when I went to 11, which is lower than 13. Okay, uh, C plus 2 actually, like C plus 2, because I defeated the first monster also, so that is cool. It is C plus 2, and SC is C plus 2, and SC is C plus 2 whenever I am creating a new score. That is the minimum. And okay, so there was a mistake. Was there a mistake in this? I think there was not. This should have worked initially. Okay, let's see, let's see. Sure. But will this work? Will this work? Shit. I want to know, will this work before submitting this? Because if I were in a actual contest and if I were to submit a wrong answer, my rating would decrease. I would get penalty, a lot of penalty, and penalty is bad because when you get a penalty, your time increases by 10 minutes. So it is okay to give 5, even 9 minutes, 6, 7, 8 minutes to check if your answer is correct. And even giving 10 minutes to check if your program is correct, just rechecking your program is cool because you are spending those 10 minutes in actually looking at your code and not just in penalty. J starts at 2 SC. Right, I'm taking in the first, which is yes. And to go up till J first, then take in C current value, and if current value is greater than equal to the current score, then I need a new score, and I would need to increment my starting value. But C plus 1 is what I need, minimum need, and SC is what I have. So that is what I add to my initial score, and else if I can go over, I will just increment my score by 1, and then I would like to sort my array, and in sorting, I am first sorting them with on the basis of the minimum cost that it takes to jump over to go through this one cave, and if two caves have the same minimum cost, then I want the maximum score that I can get after I get out of a cave. And initially my answer is 0. Yes, my answer is 0. I won't be able to enter any cave with an answer of 0. And currently my value, my score, current running score is also 0. And then I iterate through all the caves, and I see if at a cave my current value is more than or equal to the minimum value, to the minimum score that is required to enter this cave, then I am cool and I can increment my current value with the score that I would get after I have gone through this whole cave. And then in the else, that is my current value is lower than the minimum required value, then I update my current value and my answer becomes the minimum value to get to this cave, and my current value becomes, I add the score that I would get after I go through this cave minus the original answer, the original starting minimum value, and the new, add to that the new answer, which gives me the difference. So that is cool. And it does work in the example, and it should also work in the test cases. Let's see. Let's see. Okay, there is something I am missing. It might be something obvious, and okay, I will look at the test case. On the third one, I got wrong on the third one. What am I missing? Wait, that is my output. Here's the question. 9. Shit. 9 arrays. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is the second one. And only 2. And this is the third one. It has 8 arrays. These are the 8 arrays. Okay. These are the 8 arrays. I need to work with this one. Okay. And what am I getting the answer? What is the answer that I am getting? Hmm. Out one test case, which is this, and that is horribly wrong. One, and this I have. Okay, what is 0, 1? What? Climb plus plus deep down below slash out. I have one test case in which there are 8 things. Now it is cool. 8 things, and those 8 things are shit. I lost the thing. Yep. This should have worked. Okay. Is there something obvious that I'm missing in this one? Now I know for sure that I am calculating this part is correct. Like, this part is correct. I have rechecked this, and then I'm trying to sort it, and I am sorting it. I am, if there's some mistake in this or this, then I am sorting it. And yep, if b dot second is not equal to a dot second, then return whichever is the smaller one, and then in the reverse order of the score that I would get them. And after that, I have my answer and current value, and I am iterating using a greedy method, taking the first one C value is greater than I data, the data that I need, the minimum score that I need to get here. If current value is greater than or equal to that, yes, it can even be equal to that, then I increment by my current value. Otherwise, make changes to my current value. This should work. This should have worked. This should have worked. Okay, let's see. Let's see the test case in which I got the wrong answer. Yeah, that is horrible. This one right here. And I should be charging my phone. And my phone acts as my camera, doubles as my camera, which is pretty cool. And it is charging now. And this is the one that I got the wrong answer for. Can I just paste? I can, apparently. And I got 20. And the correct answer apparently is 19. But I got 20. Okay, we will have to now diagnose this one. After sorting, let's print the whole data structure. See out first the data I dot second, the minimum value that I would have, that the minimum score that I need to go to this cave, and first then the size of that cave. Right, and then blank again, and out 1 8 and paste the whole shit, my bad, this whole thing. And it turns out I need 20 for all of them due to some reason. 20 is the minimum thing that I need. No, 20 is the score is shit. 20 is the minimum score that I need for any of them initially. Can I not go with a score of 19? Okay, there is something wrong with the way that I'm calculating the score. The minimum score to cover a cave completely. There's something wrong with my method. So here, answer is 23. And since the first value is 23, and here the answer should be 7. But it is not 7. It should be 7, but and it is 7. It is for this one. That is cool. And it is 7. Okay. And for this, the minimum is 20. And here 23. And here, let's say 6. 6 works here. And the score would be 7. 7 can go over 6. Therefore, the score would, and yes, later we have 24, and the score would not be greater than 24. So answer would be 25 for this one. And for this 11, and yep, I won't be able to cross 24. So that is it. That is it. Yes. And for this score is 20, and for this also it is 20. So they are saying that if I do this, then I should be able to do something. With a score of 8, I should be able to cross some cave. With a score of 19, that might actually make sense. Wait, no. Shit, when I exit this cave, makes sense. Does it make sense? Does it make sense? Yes, it makes sense. When I exit this cave, my score is this thing. My score is 8 when I exit this cave. Shit, okay, okay, okay. Current value. If this is this, then okay, just add the score, and if not, then initially this okay, makes sense. Okay, that makes sense. So the way that I'm calculating this whole thing is correct, but this here is wrong. I'm not applying the greedy approach correctly. Okay, okay. Whenever I can go, I would go, but whenever I cannot go, I have to see. My answer cannot be equal to just that minimum string because my current value is equal to something, and my answer should be, instead of this, okay, and new answer, NANS, new answer should be the the score that I need for this one, which is the second minus the current value score I need. Yes, minus the current value. This is how much more I want my answer to be, and to this I add my answer. No, I do not add my answers. This is what I need. This is what I need at the start. So after when I'm done with this, my score would increase by the number of monsters there are in this current cave, and the difference in the initial answer that I would need, and that would mean answer plus equals new answer, and current score would be 8, and current score would be 8 in the example that I'm getting the wrong answer. After going through the first one, my current score should be 8, and answer should be equal to should be 7 initially, and my current value would be equal to 8, and this thing is 20 minus 8 current value 12. My NAS is 12, and I do data I first plus NAS, that is 12 plus whatever the value is, that does not matter. But am I getting the right answer? Answer would be 7 plus 12, which is 19, which is very cool. Plan dot slash out, and let's and I have one test case with 8 things in it, and it is this thing, this whole thing. Let's see, 19 is very cool. That makes sense. Okay, okay. This should work. That was the only oversight that I was having, and now it should be cool. It should be cool. It should be cool. Hopefully, 46 minutes gone. It should be cool. Hello, real Bebra. And it is actually, it is very, very cool. Actually, it is like amazing, amazing. Cannot be better. Okay, I was able to solve this one in 46 minutes, but I also had to look at the wrong test case. But that is a luxury I or anyone cannot afford during a contest, because during a contest we do not get the test case in which we are getting the wrong answer. So we just have to revise and look at our code and find where we might be messing up. So this was not actually very good. No pat on the back for this one. But I can say here 40, it took me 46 minutes and I had to look at the wrong test case. Not the not that the test case was wrong, I was wrong. Yo, and yep, this is cool. It uses greedy algorithm and yeah, greedy binary search. Binary search. Sorting is cool, greedy is cool, but binary search. How do you apply binary search in this question? That does not make okay, okay. No big deal, no big deal. Just a guy writing a blog. No big deal. Very normal thing for a guy to write a blog here. Shit. Okay. And shit. Usually when you write a blog, you have a drop down. You click on the drop down, and then the solution for that thing comes down. But whoever this guy is, this person named tourist, he did not do that clearly. Okay. Consider. Okay. So this is the whatever I'm going to read in this was written by this very normal dude called tourist. Right? He is very normal, I suppose. And consider a single cave eye. Suppose that the hero enters the cave with powers X. To beat the first monster, X has to be greater than AI plus 1. That is AI plus 1, AI1 plus 1. After that, the hero's power will increase to X plus 1. And to beat the second monster, X plus 1 has to be greater than AI2. Continuing this reasoning, we can write down KI inequalities. Right. Right, right. Shit, okay, okay. That is how this guy, whoever he is, he thinks. Okay. Then BI, okay. Here I need X to be at least this. Okay, that makes more sense than the shit that I wrote. Here, right. Data I dot second equal to, or I don't even have to do this thing here. Not even take C in here and make it equal to J and make it equal to 1 equal to minimum, and I can initialize this when data I dot second equals 0 and not not yeah, 0 is fine because I'm looking for the maximum value that I would need. And so for whatever this current value happens to be, I need my score data I, either whatever my current score is, or data I dot second, or yes, minimum dot second. Dot second. फिर उससे जी, okay, and or okay, that is somewhat wrong, this thing, or the other side would be data I Now, the current value C, I need C plus 1. And what have I gathered till this point is J. So take that. Right. Take that. Initially, I get no increment and this thing. I should get the right answer now, or maybe not so much. Okay. What's the second one? G should be 1 and C plus A 15. 13, 13, 13, 4, 13, 15, 13, 13, 14. Okay, how is he? Okay, before looking at how he is doing this thing, I do understand this part, and I need to find a x that satisfies all of these inequalities. Okay, let's see how I can find such a x. No, before that, let me theorize. So I need to find an x that satisfies all of these. So that x that satisfies all of these. X, I can take minimum value of x where this thing is true. Nah. Well, let me look at this, what he says. Let bi equal to maximum of, that I can take this one on the other side. Okay, okay. So I would get the maximum value which I want my x to be greater than. Shit. That is actually cool. Okay, equals maximum of the value that I already have, or the current value would be data, and the current value that I need would be C minus J. Yep, C minus J. Initially J is 0, and then data I dot second plus plus, or what I would like to have is either the current value would work, or I need this thing. Okay, that is cool. That is cool. That does work. Find the maximum value. Okay. He got to this method using inequalities. Okay. Algebra. Read about algebra. I would have to read about algebra. That is cool. Okay. Let bi be equal to this. Then I want x to be greater than bi. Therefore, x would be equal to bi plus 1. The hero can enter cave I with value x if x is greater than bi, and the hero's power will increase by ki, which is the number of monsters in this current ith cave. Armed with this knowledge, we can determine, armed, he used this word. Armed with this knowledge, we can determine the best order to visit the cave for the hero. Yes, we can. Can we? He's asking a question with a question mark. That is cool. It turns out it is always best to enter the caves in non-descending order of BI. In non-descending order of BI. That makes sense. That makes sense. And that is, go to the smallest one. Go to the smallest one, and do not go to a cave that has a bigger BI, and then go to a smaller cave, which would be bad. If the hero can enter cave I, he should always do that because entering a cave never makes things worse. This is very important. Entering a cave never makes things worse. So enter the cave if you can. It is only going to make things better. And if the hero enters a cave, because we are using addition here, addition is like always kind of good. If the hero enters a cave with greater B right before a K, if the hero enters a cave with greater B right before a cave with a smaller B, he might have entered them in the reverse order, entering a cave with a smaller B and increasing his score by Ki amounts for that specific cave, and maybe might be his B, his score might have increased beyond this B, this higher B, whatever it was. Let's sort the caves accordingly. Assume this thing less than or equal to. What is the smallest power the hero can start the level with? Well, actually, if that is true, now I do not have to sort it in this elegant way. Uh, I can just sort it like this. Yep, this would work. And okay, let's sort them, and we can assume the same reasoning that we used for a single cave and go, going caves. And suppose, yes, the same reasoning that we used, because here we had this thing increasing by 1, but now we would have this thing increasing by ki value, like shit, yes. See, ki, k1, k2, stuff like that, and find the maximum here and give the answer. So I would like to do that. Okay, this maximum implementation is cool, and I'm almost simulating this thing. Yep, I'm almost simulating this thing. Simulation is not good if you can get to the answer with a somewhat direct formula. But this is cool. This is fine. This is fine. This is fine. I mean, I am getting the right answer, but I'm trying to optimize. But this is fine. This is fine. This is how things make sense to me. So, and also this is what this works. So that is fine. And I could up the strip, and that is cool. Okay. But there was no binary search, right? There was no binary search there. Why would there be any binary search? Holy shit. Hello. And it has been, shit, I had this thing up. My bad. My bad. It has been 3 hours and I have only done 3 questions, which is not good. I skipped one, so I cannot count that one. I want to do at least 5. So in the next 1 hour, I want to do at least 2 more questions if I could. Let's go. Box fitting. Shit, maybe I have heard this one. Shit, this will use dynamic programming. Okay, I can stuff up my timer, put this thing up, problem solving mode right now, and I will go into the problem solving mode, whatever that is, and solve the question. Height 1. Width. height. Okay, it is 2D. So shit, okay, it is 2D. I thought it is 3D, and then why are they not talking about width, breadth, and height? Greedy algorithm, yes. No, greedy is not going to work. Greedy algorithm will not work in this. Nope, greedy will not work. Dynamic programming. Dynamic programming. No, greedy will work. If I begin with the largest one and then see the next one that I can take. Hmm. Hmm. I could use binary search and it will work. Okay. Uh, okay, yes, and 10 power 5 equal to 10 power 5, so 10 power 5 plus 1. Yes, dot fill, right? Forward iterator and reset, reset, reset. Okay, my visit dot reset. Shit, where did my ghosty go? And why do I have a dictionary open? Okay, shit. Yeah, yep, yep. Things are fine now. Yep, cool. All reset, everything is 0 and answer initially 0. Upper limit, upper bound for okay, and I minus. So I get the value that is either equal to or lower than my remainder. I can I c- can now change my remainder and see if I do not find any such. If my remainder is very low and I do not find any such value, then it will point to the first element. That is, if it equal we dot begin, which is the lowest size, and I cannot even fit the lowest size, then answer plus plus. I have to find some new space and rem equals w again, else do this, find the value that I can add and rem minus equals go to IT, whatever the value is at this current iterator, and bit set for IT minus a dot begin index equals 0. That is, I cannot choose this one, but before using it, I have to see that again. If this is not the case, then while bit set ita dot begin, while not bit set, then it minus minus, and one initial minus minus. I cannot use this it thing here, then I keep going back to the smaller and smaller numbers. Yes, and to the smaller and smaller numbers. And this will increase my time complexity to linear shit. So this is bad. This is bad. This is bad. So I would like to remove elements from the middle, which is also bad. Okay, I can save time. I can save time. I can do this. And then check if it equal a dot less than a dot begin. That is, we like messed everything up. Not and it greater than or equal to a dot begin. And here I am doing even when it equals a dot begin, go and decrement it, and going before beginning of an array is undefined behavior, which might result in something bad. So I have to avoid this, but maybe it is answer, so I can do this, right? And here I will check if it is greater, then I can use it. I can go to the current place and do my work there. If no, I cannot do this. I cannot do this. I can only do if it is greater than this or equal to it. And if it is equal, then I have to check that the current BS value is positive. This thing and the current BS value, BS and BS it minus a dot begin. If that is the case, then go. Else, that means I didn't find any values that I could use, in which case answer plus plus and rem equals to w. And I feel like I am messing up quite a few things here. Upper bound it equals upper bound a dot begin. I'm finding the upper bound. Okay, that is cool. And I'm iterating from the last element to this place. That is also cool. Right. That is fine. That is fine. And for this current value, where whatever it is, I have to see if BS for I, if this thing hasn't been already added. Only then do all of this. Only then do all of this. Yes. Okay, find the okay, I am decreasing my range every time. Okay, after every step I am decreasing my range. And okay, if there is current element that I haven't added to the box, then I find the upper bound. And if I cannot add this element here to the upper bound, then I should add it. Yep, yep. No, I don't have to, because I would never be looking there, because I would reduce by 1, so I would never be looking there. Uh, yes, I would never be looking, which is bad, which is bad, which is bad, which is bad, which is bad. So I will have to do I plus plus here, so that I get to see this number again, or I know for a fact that I can add the biggest element right now. So I can do rem minus the length of the biggest number right now, which is AI, right? That is the new preventer. And then otherwise, if there is an IT and IC, can I go to this iterator place? If I can, then just remove rem, set it bit set equal to 0. Here I don't need to set the bit set because I have reduced my range already, and this then rem minus equals to the biggest element, which is AI. So in every case, here I am adding the biggest element. Here I am not addressing the fact that I am not adding the biggest element. So I plus plus, so that my range does not decrease. And 9. This might not. Yes, makes sense. Makes sense. Makes sense. Which means I never did anything with the answer. I never incremented my answer, and I still was able to come out of this loop, which means it is messed up shit. I never went in because of this. If this is 0, that means I haven't used this thing, right? If this is 0, but not this, that means I haven't used this thing. Okay. If 0, then that means I haven't used this thing, and whenever I'm checking BS, I have to change it. While I have used the current element and this, then keep doing this. And if I haven't used the current element, that is, it is 0, only then go in and put this equal to 1, indicating that I have used this number, and I am getting the right answer due to some reason. I shouldn't. Okay. Why is this working? Okay, let's see. Let's see if this works. But I do not want to just submit it and hope that it would work. I cannot do that. Hope is not a strategy, not a good one, at least. So I can spend 5 minutes, at least 5 minutes, or even 10 minutes is not bad, reviewing my code. So I take in n and I take in w like this, and then I create an array, and then I take in array, and then I do this. And what, and before everything, I am doing bs dot reset, which resets my bit set to 0, and 0 indicates that the current element, whatever it is, I haven't used it. And then I am sorting my array from the smallest to the biggest box. And my theory is that first I will use the biggest box right now, and then I will find the biggest box which I can fill in the remaining space, and then so on until I cannot even fit the smallest remaining box on this place, in which case I will increment my number of rows that I'm using, the height of the column, and repeat the same procedure again on this new space. So answer initially is 1 at least. My height has to be 1, and remainder, that is the remaining space that I have, is initially equal to the whole width of the box. And then I am iterating with my range. My range starts from the first smallest box and till the biggest box, which is at position n minus 1. And if b is not, which means bullshit, no, which means not bsi, that is bs is equal to 0, which means I haven't used this last biggest box that I have. So I find an iterator which, starting from the current box till I plus till current box plus I plus 1, that is my whole range, find the upper bound in this range on this remainder. And what does this upper bound function does? It takes in a range, that is this thing that I have provided here, and then it takes in a number and it returns an iterator to the biggest, to the smallest value that is larger than this remainder. And if such a value does not exist, then I want if it equals a dot begin. Yes, because I am looking for the smallest value possible. And I'm looking for the smallest value that is bigger than remainder. So if I find the smallest value, I'm looking for the largest value that is smaller than the remainder. And if I find the largest value that is lower, that is, if I find, wait, let me show you actually. So let's say my remainder is this much, and I find this value, the smallest value that is larger than my remainder. And if I do iterator minus minus, then I will either land at a value that is either equal to my remainder or a value that is lower, and that would be the best possible fit case. And then I see, is this smallest value that is bigger than my remainder equal to the first value? If that is the case, then I cannot add any of these values, because even the smallest value, that is a dot begin, is greater than my remainder, so which is bad, which is very bad. So I cannot add this thing. If I cannot add anything at this case, then my number of height increases by 1, and on the new, in the new space, I will have w as the remaining width. And now I know that when I have a full free row, I can add the biggest box, the biggest remaining box, and that is why I'm doing remainder minus equal to rem I. And then in the else case, that is I do have an iterator to the largest value that is smaller than my remainder. In that case, I am checking, has this value already been used? If it has not been used till now, I can remove that value from my remainder, put bs, that is bit set, equal to 1 for this current box, That is, I have already used this box now and increment I by 1. And why am I doing that? Because if I do not do this, then my range would decrease by 1, and I do not want that to happen. And given the fact I want to include the last number. Wait, I am looking for upper bound here. What if I can add the biggest box right now in the remaining array? If I can, then then I would. If I can, then I would. I am even getting the right answer. So yeah, that seems correct. That seems like it should work. Why? Neurosaki. Vim is very good. This is C++. This is C++, and Vim is the best editor out there. And it is running. I might get wrong answer. Time. Okay, okay. It is taking a lot of time. It is taking a lot of time. Why? Why? I'm first sorting the whole thing, which is fine, which is fine. But then I am doing this a for loop, which is fine. But inside this for loop, I am at one point incrementing I. And this might be very bad. This might actually be very bad. This might be very bad. Yes. Time limit exceeded. So I have to make my answer more optimal, and that would involve when I have an iterator, I have to see how far along can I go with this iterator to my left. How far along can I go with this iterator to my left, and that would be cool. That would be cool. But time limit exceeded. Time limit exceeded is bad. Time limit exceeded is bad. And I should optimize this. And shit, I actually do not feel up to the task right now. Guess it is one of those bad days. Here the something like this. So in this case, I'm essentially wasting the thing. 10 is the thing, and shit, maybe I could never. 10, I'm looking for 10. Okay, I'm looking for upper bound here, right? I'm looking for upper bound, and given this remainder initially would be equal to 10 in that case, and this thing would include every single element, and it is not equal to beginning just because, yes, because I'm looking for a bigger element. So I would go into this and I would do iterator minus minus, which would make me go to the last element. And why I'm checking this thing, which is always true, while true, which it is not true, it is false initially, and iterator is greater than begin. It is, so I would not, it is big, it is greater than a dot begin, but this thing is false. So I go out and I see if iterator is greater than begin or equal to begin, which it is, and bit set for this thing wherever I am currently is false, which it is. Therefore, remainder would decrease and remainder would become equal to 2. So I only have to do this I plus plus when my iterator does not point to the last element. Okay. If a dot end minus it greater than 1, it should be equal to 1 if I am at the last element. And if it is greater than 1, then I am not at the last element in this given range. Okay, the range is still I. So if a dot begin plus I plus 1, that is my whole range, and minus iterator. Iterator, if this not equals iterator, then I plus plus. If in this current position, if I didn't use my last element, then I plus plus, and this is the last element. Um, I iterator plus I is inclusive, and if I'm using last element, it should be equal to this thing, and if it is, then I will not increment my I. Oh, okay, this is correct, and this should fix this thing, which I can actually test. Plain plus plus, and here we have the box fitting out or slash out, and only one test case in which n is, let's say, 5, width is 10, and then 4 eighths, and answer is 4, which is very cool, which is correct, and I should get the right answer now. See, I should get the right answer now, and I can remove this thing, and okay, that is fine. Yeah, or maybe no. Okay, I will get the right answer for this. My algorithm is correct, but just the fact. Okay, I will only look for an element like that if 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 I cannot already use the biggest element that I have. If the biggest element that I have is AI literally is the biggest element that I have. If AI is greater than remainder, only then do this. Only then do this, and else if it is not, if it is smaller than the, if AI is smaller than or equal to the remainder, then rem minus equals AI, and that is cool, and it should work here, and it should also work for this simple test case that I wrote. 1 4 10 and then 8 8 8 8. Yep, it does. But the thing is, how is the time complexity of this thing? The time complexity could be quite a bit, and I would not never get this luxury to test, to keep submitting again and again during a contest, because my rating would decrease. My shit, I would get penalty, and it is still wrong. Time limit exceeded. Shit. Okay, I would need some clever optimization technique here, I guess. And it has been 3 hours and 45 minutes, and for today Let's keep this at this. 3 hours 45 minutes is fine. It's fine. It is fine. It's not bad. And for today, this would be the end of my stream.